Okay, good morning, afternoon, or evening, everybody. Welcome to the Explore, Access, and Customize ICESat-2 data at the NASA NSIDC DAAC webinar. This is your host, Jennifer Brennan. I've got 2 p.m. Eastern Time, so we're going to go ahead and get started here. What I'd like to do first is go over just a few webinar logistics. To ensure the best audio experience, participants have been placed in silent mode, but if you have any issues or you have any questions, what I'd like for you to do is to enter those into the Q&A pod, and you'll find that located on the lower right-hand side of your screen. And again, this works like a chat. Today's webinar is being recorded. The recording will be posted both to our online Adobe Connect webinar catalog, as well as to our NASA Earth Data YouTube channel within a few days of completion. And then what I will do is I will, once this has been completed, I'll send an email to all registrants with the recording links. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstration and an additional 15 minutes for the question and answer period. Once our speakers for today have finished with their presentations, we will transition to a final optional set of polling questions. We'll give these questions about 3 to 4 minutes or so, and then from there move directly into the Q&A period. And then depending upon the volume of questions that we receive today, we'll extend the Q&A period an additional 15 minutes from end time for those of you who may wish to stay on the line, with a hard cutoff of 3:15 p.m. What I'd like to do next is move along to today's agenda. Let me pull that up for everybody here. During today's webinar, we will have 2 speakers. Our first speaker, Steve Tanner, is a data manager at NASA's National Snow and Ice Data Center Distributed Active Archive Center, or NSIDC DAAC. He will begin the webinar with an introduction to NSIDC DAAC and the ICESat-2 mission. From there, we will transition to our second speaker, Amy Steiker, who is the NSIDC DAAC Data Services Lead. She will spend the majority of today's webinar going through a series of live demonstrations that focus on how to discover, access, and customize ICESat-2 data using both the NSIDC DAAC web resources, OpenAltimetry, NASA Earth Data Search, and NSIDC-specific data access and programmatic resources. With that, it is my pleasure to introduce today's first speaker, Steve Tanner. Steve?
Thank you, Jennifer. And yeah, I am with NASA's National Snow and Ice Data Center Distributed Active Archive Center. For those of you keeping track of the acronyms, that's NASA's NSIDC DAAC. And today, Amy and I are going to talk about ICESat-2 data access and use. And let me make sure I can move these. There we go. So this is an image of ICESat-2's instruments. And I think I have a pointer here. And the 6 lasers that are coming out of that instrument. The instrument itself is called the Advanced Topographic Laser Altimeter System, or the ATLAS system. And it shoots photons down at the Earth and counts how long it takes a few of them to return back up. And thus it's able to use that to determine the height of the surface. Now, to some extent, it's also able to measure atmospheric information and bathymetry, which is the depth of the water, in ideal circumstances, maybe down to as much as 30 meters. And some stats on the instrument itself. There are 6 lasers, as I had mentioned, and here's a notional picture of the spread of those. They're about 3 kilometers between each pair, so the orbit yields in a cross-track distance of about 6 kilometers. And the pairs themselves are about 90 meters apart. And what this allows the system to do is it provides much better across-track vertical slope measurements. And that's a key component of what they were trying to get out with ICESat-2. It's especially important for looking at freeboard of sea ice, and freeboard meaning the height above the water of the ice. The satellite will repeat orbits every 91 days, meaning that it will measure an area, a given area, about once each season throughout the year, so about 4 times a year. Some stats on the resolution of the data. For land ice, they're looking at around 10 centimeters vertical resolution. For sea ice, down to maybe 3 centimeters resolution. Vegetation, not quite so. Vegetation is a little bit more difficult to work with. So they're talking about 3 meters of resolution, and for inland waterways, 10 centimeters of resolution. The satellite was launched on September 15th out of Vandenberg. Both Amy and I were lucky enough to be there, and it was quite an exciting event. And we at NSIDC made the data first public on May 28th of this year, after the science team were done with all their calibration and validation exercises. So that was the instrument. So let's talk about the data itself. Here is here is the family tree of the data, and we've published up through the level 3A products. That's this row of products right here. And the 3B products have not been released yet. They're still working on those, but those should be coming out. We'll see when they come out, but not too much longer. And the ones that we're primarily interested in today will be the ones that are highlighted here. ATLO3 here is the photon measurements themselves. And then the rest are divided up into more general areas like land ice, sea ice, vegetation in inland waterways, ocean elevation, and then some atmospheric data as well. And with that, Amy's going to take over and talk about how to work with and access that data. Amy?
All right. Thanks, Steve, for that introduction. So he gave you a brief intro to the mission, the instrument, and a general overview of the data products. But I'm going to move now into a demonstration of the resources available through the NSIDC DAAC. And as Jennifer walked through, I'll start with a quick navigation of NSIDC's website, including the ICESat-2 mission page and individual data set pages to highlight our support resources. And then I'll dive into some of our tools for discovering, accessing, and visualizing the data. And as you'll soon see, we have a lot of options for getting the data and a lot of various services that we provide. And these all have different benefits or use cases. We know that not everyone's workflow or research goals are the same. So I provided a couple of scenarios, and we'll kind of work through all of these different resources kind of within the context of these scenarios. So the first one is I want to visualize ICESat-2 elevation data over my time and area of interest prior to download, so kind of discovering and looking at the data before actually getting it. The second is, sort of the next step. I've looked at it, now I want to access and customize. So that includes services like subsetting or cropping the data or reformatting, and doing that in bulk. And the third is, I'll show some ways to do this through some web interfaces, but the third is wanting to do this programmatically so that I can access and analyze the data in the same sort of Python-based workflow, and that's the language we'll be working with today. So you're welcome to follow along in your own browser, but I'll also point out some of the online tutorials that are already available for some of these methods, so you can always come back to those resources on your own. So I will go ahead and share my screen now. So we should be on the NSIDC.org homepage now. And you can quickly get to data sets filtered by key science topic by clicking on these icons here like snow, glaciers, ice sheets. You could do a free text search, or if you know the mission or collection of interest, you can click on this selected data collection button. So we know we're interested in ICESat-2 data, so I'll go ahead and click there. And that's going to bring us to the ICESat-2 homepage. Now, if you just want to start at Google, you can Google NSIDC ICESat-2, and this should also be the first page that comes up. So I do want to point out just a few things. Under News, which is this first box on the left, you can sign up to receive, to get added to the ICESat-2 mailing list, but I do want to note that you'll automatically get added to our mailing list once you download the data. You don't have to do this manually, but that option is available if you haven't downloaded any data yet. So moving over to the left-hand navigation, I'm going to click on this ICESat-2 datasets link. And this has a table of each ICESat-2 dataset that's currently available for download. And that table also provides coverage, resolution, key science parameters, so you can easily compare across the data sets. Now, as Steve mentioned, but I'll mention it again, all data sets up through level 3A are currently available, and these data are provided as one-dimensional arrays of surface height, geolocation, and associated quality parameters for each of those 6 genes that Steve described earlier. There will be additional level 3B data sets, and most of those will be available as gridded data. And we'll make sure to announce the release of those to our mailing list as soon as they're available in the coming months. But in the meantime, you can read about these under the product descriptions link here under level 3B. So if you want to get a summary of those, you can do that by clicking on that link. So I'm going to scroll down, and I'm going to be working with ATL08, which is the land and vegetation height data set. So I'm going to go ahead and click there, and you will land on the data set homepage or landing page. Now, all ICESat-2 data sets, and every single data set for that matter, does have a homepage, and this is sort of your one-stop shop for information and access to the data. So I'll walk through some of the information here. You can see there's a couple of tabs at the bottom, and at the far right of the tabs, you'll see this green service icon. And that is our level of service indication, and it provides the level of support, or gives information on the level of support that we provide as far as data integrity, documentation, and user support. So if you hover over that, you get some more info, and you can see in this case, we do provide the highest level of support at the comprehensive level, and we provide that level across all of our level 2 and level 3 data. So this overview tab, it includes some key parameters that may be of interest, including file format and coverage. And I will mention here that all ICESat-2 data are available in HDF5 format, and I'll point out some resources for how to work with that format, as well as some of the reformatting services we offer, in case you're interested in working with a different format. I'll come back to the Download Data tab in just a moment, but I'll click on the Citing These Data tab, which, as you may expect, provides citation information. The User Guide tab, this provides a lot of helpful information on the data set, including how the data are structured and organized, how they're geolocated, how they were generated, etc. And just as an example, I'm going to click on the table of contents and click on file information. And I'll just kind of go through some of the information here. So there's a nice overview of the instrument and mission design. Once we get that loaded up, I know there's a bit of a lag here. There are diagrams of the 3 beam pairs, which you can see as I scroll down. You can also see how the data granules or files are divided, how the data are organized kind of within each file or granule. And you can also see some of there's more information on some of the primary variables of interest. So I can spend a whole different hour just on this information, but I'll leave it at this for now. I encourage you to read this on your own as you're starting to dive into the data. So I'm going to scroll back up to the tabs. Now, if you're looking for more in-depth information on height retrievals and how specific variables were derived, the Algorithm Theoretical Basis document, or ATBD, is available under the Technical References tab. And also included here, so that's that last link at the bottom, but also included here is the data dictionary, which provides the name, data type, and description of every single variable contained within each granule. There's also this known issues document, that's that middle link, and you might have already noticed that displayed in the banner at the top of this page. That document was created by the data authors and contains several known issues that kind of came with this initial version 1 release, information related to uncertainty, filtering, signal finding, etc. So that's another document that I encourage you to read more about. And last but not least, under the Support tab, there's some information on, there's how-to guides as well as frequently asked questions about the data. So in this case, we have some information on programmatic application programming interface or API data, access to the data, which I'll talk about later, a primer on accessing data across the ICESat-1, the ICE Bridge, and ICESat-2 mission. And I will point out this FAQ in particular here, and I'll open that up on what subsetting and reformatting services are available for ICESat-2. Again, I'll wait for that to load up. But I will mention that for most data sets, we provide spatial subsetting by bounding box or inputted KML or shapefile polygon. We also provide temporal subsetting subsetting by parameter or variable, and several reformatting options, including ASCII and NetCDF. And for a few of our collections, including ATL8, we also provide every shapefile format, which, because of this one-dimensional structure that I'll show, this could be really helpful if you're kind of looking to work with the data in a GIS application. And I'll walk through how to request these services in a minute. So I'll head back to the landing page, and I'll work through now some of these discovery and access methods. So I'm now going to go back to the Download Data tab, which I hadn't shown yet. Make sure my Wi-Fi is off, see if the Ethernet connection helps with that lag a little bit. So I'm going to focus on that first scenario of discovering and accessing a data set and wanting to visualize it first. So under this Download Data tab, I can use this interface to quickly access the data, and I'll show that in just a moment. But again, I want to do some exploration first. So I'm going to click on this Other Access Options button, and there are a few great resources here for accessing and discovering the data, but I'm going to focus on OpenAltimetry for now. So I'm going to go ahead and click there and open that up. And again, that might take a minute to load, but what OpenAltimetry is, it's a web interface designed specifically for ICESat 1 and 2 discovery and access. And what's really great about this tool is it allows you to focus on a region of interest and actually view the elevation profiles of those data with on-the-fly plotting, and you can also download the associated data as well. So I'm going to go ahead and click on the red Browse ICESat-2 Data button, and that will bring us to a map interface. And again, I know it takes a few minutes. Looks like that's loading up, though. So what you see here, you see a bunch of green lines and a couple of dots and a calendar. So what you're seeing here, those green lines indicate the reference ground tracks for the most recent date that we have data available. So currently, the most recent date that we have is February 23rd. That's what you see on the calendar. And I'll just unclick that. And what those green lines indicate, you should see about 15 or so of those. And those are tracks indicating the 15 or so daily orbits. So again, this is a single day that we're looking at. And you can think of these reference ground tracks as imaginary lines falling through the 6-beam pattern of the instrument. It kind of gives you a sense of where the data exists. So again, you really can only see those tracks as well as a few dots. And those dots indicate the data segments. And I'll describe those more in a minute. There's a percentage indicator on the left, though, and that shows you how much data are displayed. And this will increase as you keep zooming in. So I'm going to start zooming in on my area of interest. And again, I'm interested in ATL08, which is the land and vegetation data set. And for this purpose, I'm interested in the Yucatan Peninsula. I'm going to zoom in there. And I see a few things happening as I zoom in. You'll start to see more dots that you might see in other places of the peninsula. Again, I think this has taken just a few minutes to load, but what you'll start to see are a lot of red lines. So again, it's a single day, and we're only seeing some coverage, like right now, some coverage that's west of the Yucatan Peninsula and east. But as you keep zooming in, you should start to see a bunch of red lines. And I know, again, it's taken a few minutes to load. But those lines do indicate other reference ground tracks for other days. And again, you'll also start to see more dots appear. And we can talk about those dots while this loads. So these indicate the bin segments of photon data. So note, currently OpenAltimetry only provides ATL06, and that's the land ice data set, and we'll work through that one in a minute, and ATL08, as well as the underlying photon data. Like Steve described, that ATL03 data set provides the photon data at the 70 centimeter resolution. So in the case of ATL06, there are segments that are provided every 20 meters, and that's with data that are actually averaged every 40, but the segments are posted every 20 meters. And ATL08, those segments are posted every 100 meters. So that's what those dots indicate. So I'm interested in this area, but I don't see any dots or green reference ground tracks. I just see these red lines. If you click on one of the lines, though, you will see information on that track and where, what dates those data were available. So I'm going to click on the more recent date in January. I'll close out this calendar. And now I'm on that day. And if I close that out and keep zooming in, now I can actually see those dots appear. So now I'm on January 15th. And if I zoom even closer, you could really start to see the 6-beam pattern that Steve described, so those 3 beam pairs that are split into a high and low energy beam pair. And those energies are at about a 4-to-1 high to low energy ratio. And the sort of purpose of these pairs is to better determine the slope across the surface. So one thing you'll notice, though, if I kind of start to zoom out, you're not really seeing continuous coverage. So especially as I go south, kind of seeing some of the data drop off. Now, there could be several reasons for this. And in general, there might be a data quality issue. One thing that's easy to check for in OpenAltimetry is the presence of clouds. So on the left side, you'll see a little cloud icon. And if you click on that, you can see a layer, and it's the MODIS surface reflectance layer. And if I zoom out just to get a bigger picture here, I will kind of see some relationship. It looks like there's more data that exists where there's less clouds. Now, this is obviously more problematic in the tropics. So this is kind of a coarse way to check. These instruments are not, satellite paths are not exactly in line. So it's not like the exact timing of these clouds matches exactly with the data. But it does give you a general sense of what might be going on with the data. So I think it could be a really helpful indicator. But I'll turn that off, and now I actually want to get to the data. So I'm going to click this on at the top left. There's a Select a Region button. And I'm going to go ahead and click that and drag my cursor over that area, and I can draw a box over the region that I'm interested in. And I think there's a little bit of a lag, but I'm just, again, drawing a box over that region. And what I can do then, it allows me to view the elevation profile of the data. So I'm going to go ahead and click on the View Elevation Profile, and a new window will open with 2 different plots in this case because we're looking at ATL08 data. So the top is a surface elevation plot, and on the bottom is the canopy height plot. Now, a couple of cool things about this. These plots are interactive, so as I move my cursor along, I can see the beam values, the latitude, elevation across both. I can kind of drag and zoom in on an area. And these are also color-coded by those beams. And this designation, you'll start to see this often within the data files themselves. So this GT3R, for example, GT means ground track. And so 3R, 3L, that's the 3rd pair, and the right side and the left side beam, and 2R, 2L, et cetera. So that's kind of what those IDs indicate. Now, again, this is at the 100-segment resolution, but I can click on this photon tab at the top, and I can see the associated photon data. And again, that's at the 70-centimeter resolution. And by default, this only shows the high confidence photons, but I can click medium and low to kind of get a sense of the quality here. So it looks like a lot of low and medium confidence in this area, which could be, again, helpful to determine, get a sense of the quality. I'm going to go back to the Elevation Profile tab, and these menus on the right side of the plots gives you options to download these images. You can download them as PNGs, JPEGs, PDFs, and CVG vector image. And at the bottom of the page, you can download the data. And you have 2 options here. You can download the data as a CSV, and I'm actually going to go ahead and do that, and it'll automatically start my download. Or I can download the data that are subsetted by that region that I drew in the native original file format, the HDF5 format, and I'll get all associated parameters. So the CSV only provides kind of a select number of parameters. And in the interest of time, I already downloaded both of these. So I will open those up in a different window. So I've opened up the CSV as well as the subsetted file. So on the left side of the screen is the CSV output in Microsoft Excel. And you can see those key parameters that you get. You get segment ID, the lat long. This is the terrain elevation height, the best fit, as well as uncertainty, canopy height and uncertainty, track beam. And the final one here is the file name. So you can see what file these data came from for provenance. And on the right, it's the same data, and I apologize, this might be really small, I couldn't zoom in. But this is the HDF5 file that's subsetted. I've opened that up in HDF View, which is downloadable software available through the HDF group. And we have a link to that I'll show later. And you can see the hierarchical structure of the file. So again, this actually has all of the variables that are contained within the file. They're just cropped to that region of interest. And you can see that they're in this hierarchical structure by beam. So each of these groups here, GT1L, 1R, has all of the same parameters, but you can get those parameters. Those parameters are available within each beam group. And I have opened up the height canopy, and you can see the same data are available there that's the GT3R group. So that's a little taste of what the data look like. I'm going to go back over to OpenAltimetry and back to my map, and I'm going to zoom out. And there's one more thing I wanted to show in OpenAltimetry. Looks like seeing the HDF view still opened, so maybe you could still follow along. It might just be a lag here. But at the top right of the map page is this icon that looks like a tag. It's in the middle of the globe, between the globe and the info button. And it's this feature called annotations. It might still look like there's two, like the HDF view is open. I'll try to close that to see if we can get that to look better. Let's see, just a second. Well, my screen, I'm seeing two different images here, but you still should be able to see OpenAltimetry on the left side of the screen. So there's a tag icon, and I'm going to click on that button, which will turn animations on. And what you should see are a bunch of dots, and these red dots indicate annotations that the user community can create and post publicly. And these might just be different areas of interest or different features that may be of interest. So as an example, I'm going to click on this View Detail button. You could see kind of what the annotation is. So if I click on View Detail and zoom out, it looks like this annotation provides an interesting feature. This is a glacier terminus near Glacier Bay. And if I select the region that was annotated and view the elevation profile, it's pretty cool. It looks like I can see some elevation across that glacier terminus, so a profile across that. So this is a really nice way to kind of get started in OpenAltimetry if you want to view these, just to get a sense of the data. And the other nice thing about it is you can share interesting features with your colleagues, and you can share them publicly. So this is just, again, a nice feature that OpenAltimetry has. All right, so I'm going to go back to the ICESat-2 homepage. And good, okay, looks like my split screen is gone, at least in the computer that I'm viewing. So I'm going back to that table that I presented earlier, and I'm now going to click on ATL-06. I'm going to work with a new data set now. So I'll go ahead and go to that landing page, and I'm going to go back to the Download Data tab. So I'm going to work through how to get data under this tab now. You know, we've discovered the data, and now we actually just we're moving on to that second scenario now. We know the data set that we're interested in, and now we want to get the data kind of in bulk across a time and region of interest. So OpenAltimetry is a great tool to really hone in on a very specific and very small area and view some profiles within that day. But this is a really nice way to get all the data over a time and area of interest. So the time range that you see at the top, filtered data by date, what's automatically populated here is the earliest date that we have of data available, which in this case is October 14th, and it goes to the present. Now, like I said, data for ICESat-2 right now are only available through February 23rd. We will have more data in the coming weeks, but I'm just going to leave this as is for now. I want all the data available. But I'm going to use the map to zoom in on my area of interest. And like I said, we're working with ATL-06 now, which is the land ice data set. So I'm interested in Western Greenland, and I'm going to zoom in and pick my area. And what you'll start to see on the right side, so what you see now, I have no filters applied. I see almost 13,000 files that are currently available. But as I select this polygon and draw a polygon here, I will start to see those files that automatically get filtered. Now, to create a polygon, it's really easy. You just kind of use your cursor to click each point, and then you double-click the last point to close out that polygon. And I'm just kind of keeping this coarse right now. But you can see on the right side that I've whittled it down to only 49 files now. And it also shows you how much data are available. So I can see we have roughly 3.5 gigabytes of data. So that gives you a nice sense of how much data we're working with here. The other great feature is you can search by file name. So under the user guide tab, I know I didn't go into detail, but we do provide guidance on the file naming convention. And in the file name for ICESat-2 data, it does have information like ground track number. So let's say you want a ground track in particular, you know what number you want. Let's say you want ascending versus descending files or different regions, which is how the data are divided. You can type in a value here, and it will also further whittle down the data. In this case, I know that the 03 region designates the ascending region over that latitude band. So lo and behold, I'm now down to 25 files, so cut that about in half. So that's another great thing that this does. So at the bottom, now we can get the data. There's a couple options here, and I'm going to show the download script. I'm going to go ahead and click download, and I'll get a download script. Again, I'll show that in just a minute. You can also order the files, though, and you can do this. What you'll get back, I'm not going to show it right now, but you'll get back either one zip or multiple zips, depending on the size of the data. And you'll also get an email notification. So this is a really easy way if you just kind of want to click and get the data as zip files. You can do this as well. You do need to be logged into Earth Data Search to do this. And all data are freely, publicly available. You do need a NASA Earth Data account, however, to access the data. So there is this button up here, log into Earth Data. It already remembers me, so I'm logged in. I can see my name. So just know that that is needed. If you don't already have a NASA Earth Data login account, it'll provide prompts for how to get one. But again, it's pretty easy to do, and once you have that account, you can get all the data. And I'll mention this large custom order in a minute. So onto the download script. I'm going to open yet another window. I'll wait for that to load. And what I have here is that Python script that we just downloaded. So again, this is available as a Python script, and I have it opened on the left-hand side of the screen. And the instructions commented out on the top guide you on how to do this in both a Mac and Windows. You can do this with Python 2 or 3. So that's just what the script looks like. Obviously, I'm showing the Mac workflow, but the Windows process is just as easy. At the top right, I have a terminal window open. And at the bottom, I've already created a webinar data folder. And I've already downloaded the Python script from a different day from last week, but it's this NSIDC download. And I'm actually going to go ahead and copy the name of this. At the top, I've already moved into the webinar data directory. And all I have to do is type Python and the name of that script. And the number of files is a little different. My filter that I did last week is just slightly different. So found 34 matches instead of what we should. I think I had 25 in the previous screen. And it's going to download the science files, the .h5 or HDF5 files, as well as the associated XML metadata. And we can see that chugging along, and there you go. We have the data. So I will let that run. We don't have to watch all 68 files download. But this just shows you how easy that is. So I'm going to head back to the landing page. And one more option that's provided under the Download Data tab is this large /custom data button. So if you have over 2,000 granules that you want, or if you want to apply any of the subsetting or reformatting options that I mentioned earlier using a web interface, you can click this button, and that'll take you to the NASA Earth Data Search application. Now, in the interest of time, I'm not going to walk through those steps, but I'll just kind of highlight a couple great things about Earth Data Search. It allows you to, again, as I mentioned, you can apply those customization options, and you can also access data over the same space and time across multiple data sets. So I mentioned this already, but under the Support tab, is a primer for how to do this with the ICESat-1, IceBridge, and ICESat-2 data sets. So I encourage you to look at that if that's something of interest to you. But that's another great benefit here if you're looking for multiple data set access, again, within kind of a single space and time, space or time. So I'm going to go back to the ICESat-2 homepage. And we've walked through a lot of web interface tools for discovery and access, but we do have several resources for programmatic discovery and access. So I'm clicking on the tools link that's on the left-hand navigation. And we have a table here that has all tools and services associated with ICESat-2. So you've already seen OpenAltimetry. Excuse me, I mentioned NASA Earth Data Search. But further down are a few resources in Python, including this ICESat-2 Hack Week Jupyter Notebooks tutorial link. And I'm going to go ahead and click on that and explain a little bit about what this site is. I'll make this a little bigger. So the ICESat-2 Hack Week, this was a 5-day event that was held last month and hosted by the University of Washington with support from NASA's Cryospheric Sciences program. And the event consisted of a mix of interactive lectures as well as participants working on projects related to ICESat-2 exploration, and there was hands-on software development as well by the participants. And a combined GitHub repository was created with all of the interactive tutorials that were created. And most of these were presented as Jupyter Notebooks in Python. So this README includes summaries of each tutorial, and I'll just walk through those a little bit. So these include everything from basic mission overview to an introduction to reading HDF5 files and ICESat-2 data, ATL06 cloud and data filtering, gridding, general geospatial analysis tools, and there's also a notebook on data access and subsetting using NSIDC service. So I don't have time to demonstrate any of these today, but if you want to explore these on your own, which I strongly encourage you to do, you can click on this Launch PanGeoBinder button. And what that does is it copies all of the dependencies or Python libraries that are needed to run these tutorials, and it allows you to open these using cloud resources within your web browser. So you don't need to do anything as far as downloading or making sure your Python environment is correct. I'll also mention that there are a lot of great repositories under the main ICESat-2 Hack Week organization. So if you just go up a level to ICESat-2 Hack Week, there is a lot more great material that was created by participants. And another outcome of the Hack Week was the development of a core ICESat-2 Python library. So this will include the common operations that were surfaced at the event, like data access and filtering, subsetting, reading in the data, simple plotting, etc. So keep an ear out for that. But I did want to mention that was a really great outcome of the event. So back to the ICESat-2 tools page. Let's see, I think it's this one that I just wanted to highlight here. This API documentation page provides an overview of the service that I've mentioned. So this is an application programming interface that provides the customization options that I mentioned that were provided in that frequently asked question. And it's a service that allows you to, in a single access point, provided as a URL, you can request a data set over time and area of interest, as well as those reformatting and subsetting services. And you can do this either at the command line using curl, for example, or any other programming language with an HTTP library or package. So this Jupyter Notebook link, that's below the Hack Week link, is kind of a Jupyter Notebook to get you started with this API. And what this is it's a Python-based Jupyter Notebook. It's available through NSIDC's GitHub, and it utilizes the API to search for and customize your data. So I'm going to go ahead and click on this Launch Binder button. This can take a few minutes to load. So I've had this preloaded if we don't get a chance for it to load. But I'll share a little bit of information about it as it loads. So what this binder button does, it allows you to open a notebook in an executable environment that's already been configured for you. You can run it within your web browser without needing to set up anything locally. So it's a nice way to just sort of quickly get a sense of what this notebook's all about and run it without having to do it locally. So if you're following along, it may take a few minutes for that to load. I'm going to go ahead and load up one that I actually already have loaded. But once that binder link loads, what you'll see is a Jupyter Lab interface. And if you're new to Jupyter Lab, what this is, it's a web-based interface that allows you to work with documents like Jupyter Notebooks, but it can also include components like terminal windows and other things. So what you see here on the left is a directory structure, and all of the different applications that you can launch are provided in the middle. So I'm going to go ahead and click on the notebook that's in that menu on the left-hand side, and it'll open up my notebook. So what this is, what we're looking at here, is a notebook which is essentially a mix of text and cells of live Python code. And these cells can be run individually, or you can run the entire notebook in a single command. So as the summary describes, this walks you through how to access data using filters, as well as reformatting and subsetting options. We'll actually request the data within the notebook. So to do this, I'll show this briefly. I'm going to go click on Run at the top and then Run All Cells. And this notebook is simple, and it kind of just prompts you through each step, which is nice, especially for demonstration purposes. So first we have to create a token that's tied to our Earth data login username, as I mentioned before, something you need in order to access the data. So I'm going to start to fill this out with my username and password. The next step is sort of a discovery step. So we can input a data set of interest here, any short name like we've been working through ATL 08 or 3. This also works for any other NSIDC DAAC data. And I'm going to, my final data set I'll work with today is ATL 13, which is the inland water level 3A data set. And now I can filter my data down. So just like we did under the Download Data tab, I can input an area of interest. So in this case, because I'm working with inland data, I am interested in the Great Lakes region. So I'm going to input this information, this box, big box over the Great Lakes, and that needs to be provided in decimal degrees. And then just to kind of make a small request, I'm just going to go over the first of the year, the first 2 days of the year. So just January 1st and 2nd. And what it does, I'll actually just scroll back up since it already moved past. But what you can see here, once we get it loaded, you can see how many granules are available over my time and interest. So in this case, there are 3 granules of ATL 13. And we can also see the average size of the granule and the total volume. So we're only dealing with about 17 megabytes of data, a little smaller than the ATL 06. And if I scroll further down, now I can request my options. So subsetting by bounding box is available. I'll say, yeah, I'm interested in that service. I can click on the temporal range, I can request temporal subsetting based on the range above. And I'll go ahead and click yes to that. You can also reformat the data. Like I mentioned, all the reformatting options we have. I'll just leave that blank for now, kind of move faster here. Variable subsetting is available. So what this does is if you just, let's say, want some of the key parameters like height, maybe a few of the associated quality parameters and not the many hundreds or thousands in some cases of ICESat-2 data, you can subset by variable. And if I click yes, I do want to subset, I'll get a list of every single variable available. And I'll actually just leave that blank for now and say, I'm not going to subset variables today, but you can at least see that list. And now it's going to download the data. So it will tell me how many orders will be processed, and you can kind of configure how many files you want within each order. And if I scroll down here at the bottom, it'll kind of give me a status on the order number and if it's downloading. And it looks like those data already downloaded, and it'll kind of clean up that folder. And what you'll see at the top left is this outputs folder. So it creates a folder, and I see my 3 granules that are processed. They're prepended with process, which means that there was subsetting done to it, and I have my data. Now, if you're using this, if you're running this in Binder, the data are not actually downloading to your computer. They're kind of living in this web-based Binder environment. So this is, again, that link is a great way to get started with this. But if you are going to start using this to download data, I do recommend working through the instructions for how to get this running on your local machine. Or even right now, if I kind of click on a file, I can actually go ahead and download it to my machine. You can also do that if you want to play around in Binder. But really the idea with this notebook is that you can kind of combine this with, let's say, other materials from the Hack Week as far as visualization analysis. And you can pair those commands used to access data programmatically along with those other visualization notebooks to get you started working with the data in more of a programmatic way. So I will just leave it at the ICESat-2 homepage to wrap up. And I want to just point out there's a lot of other resources that I didn't really get a chance to cover in detail. You might have seen as I scrolled past in the tools table, I scrolled past our data subscription service. So that's another one I just want to mention, which allows you to subscribe and receive the data as they're ingested at NSIDC. There's plenty of other materials. I also want to mention that we have an extraordinary user services team at the NSIDC DAAC. So if you have any questions in the future as you start to work with the data, you can email us at nsidc@nsidcdac.org, and that contact info is provided on every support tab of every dataset page. You can also click the green support button at the bottom right. That's available on every single one of NSIDC's pages, and you'll get the help you need. So with that, I will hand it back over to Jennifer.
Okay, wonderful. Thank you, Amy. At this point, what we'll do is we'll transition to an optional final set of poll questions. We'll give these questions about 3 minutes or so, and then from there, we'll transition directly to the Q&A. So thanks, everybody. Let's give these about 3 minutes, and then we'll continue on to the question and answer period. Okay, everybody, we're going to give this just another minute, and then we will move to the question and answer period. Okay, everybody, at this point, let's transition to the Q&A. And we did have a question pretty early on here. And if you just give me a minute to locate that. The first question was, could you describe the difference between the 3A and the 3B processing?
Yes, Steve, I didn't know if you wanted to take that, but
so basically the 3D products are the are true level 3 products in that they are gridded, and that's the primary difference in a nutshell. But Amy, do you want to elaborate on that any?
Yeah, like I said, I think almost all of the level 3Bs except for one are going to be two-dimensional, so they will be gridded. Most, I think, will be available as HDF5 files. I think there's still some of the formats are still to be determined. Like some of them are also time aggregated with a really large time range, so they may not be available for quite some time. So a lot of them are still in development. But yeah, the idea is that they will be gridded, likely available as HDF5. Some might be available in other formats. We'll certainly also have reformatting options available like GeoTIFF. But that's the basic idea. They're time and space aggregated and mostly gridded.
Okay, great. Thanks, both of you. So the next question is, will there be a way to input a specific latitude, longitude in OpenAltimetry? For instance, I am the lead for a student research campaign looking at tree height and a citizen science effort looking at tree height as well. Participants would like to be able to input their latitude, longitude, and see when ICESat-2 provides data for that area for ground-based and satellite data comparisons.
Yeah, that's a really great use case. Steve, do you want to chime in?
No. Well, you know this as well, but in OpenAltimetry, there's not a way to put a direct lat line, is there?
I do not believe so currently. Yeah, it's really kind of that workflow of kind of zooming in, drawing a box, and then getting the data that are available there. However, you know, this application, since it's so new and the mission's so new, we certainly welcome feedback on enhancements to the application. So that's a great one. I wrote that down and as something we could see if that's on the horizon as far as development, but I'm not sure if it is at this point.
But the ground tracks are listed, aren't they? I mean, you can see all the ground tracks, right?
Right. Yeah.
So what?
Correct. This is Sarah.
Go ahead, Sarah Jota.
Hi. So I just got off a telecon with the ICESat-2 developers. The Zoom to user-specified lat long has been on the list of things to do for. I entered it, like a month ago, and it was just prioritized, and so it will be coming shortly. We plan to add a gazetteer as well, so you can say go to San Diego, and it will use the service. Look up the coordinates for that and zoom to that location as well. We're also talking about adding additional base layers, geopolitical base layers, so you can, go by recognized city names or political boundaries.
So thanks, Sarah Jota. For those of you guys that are not familiar with Sarah Jota, he's one of the primary movers behind OpenAltimetry. So that's straight from the horse's mouth there. The other thing I was going to suggest is if you are interested in a specific known location, like say your house, you can look at the ground reference tracks that are in OpenAltimetry and also available through other resources and see which ground track is going to be passing over or nearest your house, and then just look at when that track will be coming over you. So that's another way to reference specific areas. I hope that addresses your question.
Okay, thank you, Steve. There's quite a few questions here, and I'm trying to respond while moderating the pod here. So if we don't get to your question during the Q&A, we'll forward all these questions along to our speakers, and they'll be able to follow up offline. Okay. So the next question is, what is the spatial resolution for the upcoming 3B level canopy height grid?
So I don't know the specific answer to that because we don't have the ATBD for that yet. But for the ungridded version, it's 3 meters for the canopy height as the vertical resolution. But I don't have any more detail in terms of the ATL-18, which is the product that you're referring to on that. I will say I think that it is the grid size is around 500 meters, I think, for the ATL-18.
Okay, thank you, Steve. So the next question is, might coastal waters inside coral reefs, such as those within coral atolls, be considered inland waters?
I don't. Go ahead, Amy.
I was going to say, I don't know for sure. I'd have to see what the ATL-13 mask looks like. I do know that there are a lot of surface areas that where some of the surface-specific level 3A data sets kind of overlap. So you actually may get data over an area that is considered actually in the vegetation mask, as well as maybe land ice, maybe inland water. I'm not sure about coastal regions, though, as far as ATL-13.
Yeah, and I will say, so the masks that they're looking at using initially, I don't think include coastal areas other than when there actually are inland waterways associated with that. I will say, however, the bathymetry that's coming in off of the instrument is looking significantly better than was originally expected. And so I suspect there will be a great deal of interest in inland coastal waterways and things that can be teased out of that data.
Okay, thanks everybody. The next question is, let me just move down just a bit here. Is there a product that provides near shore or coastal bathymetry?
So that's what I was referring to. So right now there is not one specifically aimed at doing that. However, as I had mentioned, the data is coming in looking quite good in those areas. So I suspect in the future there will be. But I don't know if we do not have one in hand that is looking at that specifically.
Right, and I'll also mention, because I didn't give the ocean data set, I didn't walk through that as an example. There is an ocean elevation product, that's ATL-12. So again, these areas again might be in those places where some of these surface-specific masks overlap. But I would encourage you to also look at the ocean elevation data set.
Yeah, agreed. And I will say in some of this data, we're seeing not only a little bit of bathymetry coming in, but also even surface wave action to some extent. So that the information is phenomenally good coming in there. It's just there's not a product specifically aimed at that that's being published as the standard set of products.
Okay, thank you, Amy. Thank you, Steve. Now moving on to our next question here. When will the new data be released? It stopped in February 2019. Forgive me if you've already covered this.
No, we did not cover that, and that's a great question. So we're taking it in phases in terms of moving the data out, and the science team is right now looking at approving the release of the next block of data that will go from February 23rd into a few more months. And we should hear shortly whether that's been approved or not to be released. And so you should start seeing some more data coming in shortly. I will say that the satellite itself went into safe mode for a few weeks not too long ago, and so there's going to be a gap in the data once the data starts flowing again off of that. They've turned the satellite back on into science mode, and they're currently going through calibration and validation of the data with it now. So the short answer is you should see data from February 3rd over the next couple of months here shortly, meaning in the next couple of weeks.
Okay, thank you, Steve. Let's move on to our next question here. All right, for the ATL 06, will you clarify the posting resolution, footprint size, and spatial averaging technique that was used?
Yeah, I mean, I could speak to at least what I was mentioning when I was going through OpenAltimetry. So each, the data are available in these segments, and these segments are averaging the photon level data into a single segment. And those in ATL 06 are at the 20-meter resolution. So you're going to see a data point every 20 meters. However, there's sort of a 40-meter moving window to aggregate the photon data. So it's like a 40-minute averaging, but then they're kind of posted every 20 meters. And I know Steve was mentioning the vertical resolution. And if you have that value offhand, Steve.
So for 6, I don't have it right here in front of me. Hang on. We can come back to that.
Yeah, so I don't know if that helps, but again, with all these level 3A data sets, you'll see you'll get a value again for 06, it's every 20 meters along track, so along that beam track.
Yeah, so vertical resolution should be under 10 centimeters.
I hope we answered that question.
Yes, and have you already covered the temporal resolution for ICESat-2?
Well, temporal, so the instrument, the Atlas instrument, as far as how frequently it's sending laser pulses down, it's at 10,000, there's 10,000 pulses per second. So that's sort of the resolution, temporal resolution of the instrument itself. But Steve did mention there's a 91-day repeat orbit. So if you're interested in a particular area, that's going to repeat. You'll get data every 91 days, at least on the poles.
Yeah, thanks, Amy. I wasn't sure exactly how to address that. So a long track, the temporal resolution is, again, many times per second. But the question is, how often do those tracks pass over the specific area you're interested in? And that's about 4 times a year for a specific spot.
Okay, thank you, Amy. Thank you, Steve. Our next question is there OpenDAAC or threads aggregation or DAAC access to ICESat-2 data?
Amy?
Yes, we do. We do have an OpenDAAC, a high-rack server that's available for all of NSIDC DAAC data. As far as our level of support for that, we're sort of focused our data access and subsetting support through the API that I mentioned, which is our sort of customization service API. And we kind of recommend using that. It's more supported. But we do have an OpenDAAC, a high-rack server, if you're interested in that as well. And if you sort of Google NSIDC OpenDAAC, you can get to it from there. But there's no like guarantee of, we aren't focusing again on testing this rigorously, but we do have it available.
Okay, thank you, Amy. Let's see here. Getting up to our next question. And I know we have talked about spatial resolution for a couple of the products. This is specific to the ATL 08 data product. What is spatial resolution? Will the gridded products be produced for ATL 08? What will be done to estimate altimetry between the ground tracks?
I don't know how to answer that question. Amy?
Yeah, I mean, again, unfortunately we don't have a lot of information at this point on the resolution of these gridded products. Yeah, like I said, a lot of them are still in development. So we really just don't know. And so as far as estimating altimetry, I think the question was across the beams, or not sure what that question was.
So it says, what will be done to estimate altimetry between the ground tracks?
Yes. Right. So I think that each of these surface-specific gridded products will probably be using different spatial aggregation techniques. And again, I just don't have the details on that at this time.
Okay, thank you, Amy. Thank you, Steve. So moving on to our next question here. Does ICESat-2 elevation product provide water surface elevation or the bottom bed elevation?
So there is there's, in terms of the height, there is an ocean height product and there is an inland waterway product that's specifically looking at the height of the waterways. In terms of the bottom, there is not a bathymetry product itself, but there is bathymetry data depending upon the circumstances, the turbidity of the water and that sort of stuff. So there is some bathymetry data coming in, but there's not a product specifically aimed at that yet.
Okay, thank you, Steve. Our next question is, can we retrieve the data using R language as well?
Yeah, certainly. So, you know, with at least the notebook I showed, it's really just it's using an HTTP package called requests, and so you can, through Python, you can sort of create your API URL, and that'll get the data back. And I believe R has a similar library or package. So as long as you can use an R package that again request data via HTTP, you should be able to use our API, as well as just pulling data down just from our from NSIDC site as well. And we're happy to provide more guidance on that. Again, that's something, if you want to email NSIDC, we can point you to some resources, but you should be able to do that through R. But we don't currently have any notebooks or tools yet for R, ICESat-2 access.
Okay, thanks, Amy. The next question is, could you describe again where the resources are for reformatting some products to shape files?
Yeah, so I didn't walk through it, but if you're on that data set landing page, you can, and under that green other access options button, you can go to Earth Data Search directly, or you can kind of walk through the filtering steps that I showed under the Download Data tab, and then click that large /custom order, and that'll actually pull all your filters into Earth Data Search. You don't have to do that twice. So through Earth Data Search, once you walk through that ordering process, you will be presented with an option to customize, and that's where you'll have a form that gives you all of those options to subset and reformat. So you can do that through NASA Earth Data Search, and then you can also do that through the API that I demonstrated through the notebook. So there's also that option to select shapefile there as well.
Okay, thank you, Amy. The next question is, and we have about 6 minutes left to the question and answer period. So if we don't get to your question, we will have the speakers follow up with you offline. The next question is, could you tell, excuse me for a minute, let's see. Can you talk a little bit about the footprint of the data? I've downloaded shapefiles in the case of to find out canopy heights and don't understand exactly what is the shape and radius diameter of every dot of the shapefile.
Okay, that's a great question. So the footprint size, and I realize I think this was asked earlier and I didn't address it, so I apologize for that. But the footprint size is about 17 meters. So that's kind of, if you're thinking about that radius, it's at a 17-meter footprint. And that's, again, per, and if that's thinking about it at the photon level, but I think you can think of that footprint size as well for the aggregated data. So those aggregated, the segment level data for the level 3A, the surface products, again, are going to be sort of averaged across a certain length, but that footprint is, yeah, about 17 meters.
Okay, wonderful. Thank you, Amy. The next question is, let's see. So it's more of a comment. So this individual has been using the ATL06 land ice data. The results are very impressive, but I've had problems filtering the data. I have full tracks with huge height errors even after applying, but I don't see a way to filter the data for orbit errors, if that's even the problem.
Okay, that's a really great. I know I'm seeing some of those answers right now on challenges people have faced as far as filtering. Yeah, so we provide subsetting options per variable, but that's sort of just a yes or no. I want this variable or parameter or not. I would recommend taking a look at some of the tutorials that I showed through the ICESat-2 Hack Week. There were some examples there on kind of filtering, pulling the data into Python and then filtering that way. So I don't know if the question's more as far as, how do I do this? So again, I'd look to the Hack Week for some examples there on filtering. If you're asking more for sort of, what should I filter against, or how to kind of determine quality, that's kind of something, and we can kind of help you with that, if we get more information from you on what you're trying to do. I would say take a look at the ATBD, take a look at the user guide, to look at the key parameters to filter against as far as data quality. But I know it's kind of just a vague answer. But again, I would maybe start with the Hack Week resources.
And I'll second taking a deeper look at the ATBD and see if that doesn't give you some explanation for what you're seeing.
Okay, thanks guys. The next question is on the ATL08, is best fit much different from the median?
I don't know.
Yeah, I don't know what data set they're referring to. Yeah, so I guess I'd have to look into more details.
It's
again. I'd probably be looking at the
the ATL08.
Oh,
That's the land water vegetation product.
Okay.
Again, that's something we have to dig into the ATBD to get an explanation on. And frankly, off the top of my head, I do not know the answer.
Yeah, I apologize. I don't either. But we can certainly try to get you more information. And again, shoot us an email, or we could get in touch with you to try to figure out if we can guide you further. But I do not know off the top of my head.
Okay, thank you. We have about 2 minutes left to the Q&A. The next question is, will 20-meter, 100-meter geosegs be available as shapefile?
I did not understand the question, Jennifer. Can you repeat it?
Sure. Will 20-meter, 100-meter geosegs be available as shapefile?
Yeah. So ATL08, the land vegetation product, 06, the land ice, and the inland water are available in shapefile reformatting. Again, you can request that through our data search or through our API, and that's basically just going to do a one-to-one. It reformats the data, so you're looking at it's in point format. So it's not line-based. So you'll actually get a point. So for each elevation that's associated with a distinct latitude and longitude, you'll see that as a shapefile as a point, and you can plot it that way. So I don't know if they're asking more for could that be converted into like a line shape, for example, but it is delivered as point data.
All right, thank you, Amy. We probably have time only for 1 or 2 more questions. Can land and vegetation height products be useful for describing seasonal snow depth evolution?
I believe so. I have heard some potentially some applications with, well, I know for sure about blowing snow, but that's more for the atmospheric data set. But I do believe there could be some applications with snow depth.
Yeah, there's a lot of there's a lot of interest in doing that and looking at that very area. So yes, there is potential for that.
Okay, well, thank you. At this point, we have reached the end of today's webinar, including the extended Q&A. There are several questions that were not addressed during today's webinar. So I will forward the Q&A log to our speakers, and they'll be able to, follow up with you offline. I'd like to thank everybody for joining us today, and especially thank our speakers, Amy Steiker, and Steve Tanner for their presentation. I'll leave the virtual meeting space open for an additional 10 minutes. If you think of something, feel free to jot it into the Q&A, and that can be forwarded along. But otherwise, at this point, we will log off from the audio component. All right, thanks to all of you, and we hope to see you at an upcoming webinar. All right, goodbye, everybody.
Thanks, everybody.
Thanks so much. All right, bye-bye.